Hello everyone, this is number 14 of the problems, and number 14 says y double prime minus 4y prime plus 4y equal to 0, and we have these two initial conditions which says y of 0 is equal to 1 and y prime of 0 is equal to 1 also. So we can see this is a second order linear equation, so let's rewrite the second order linear equation. We can say that r to the power of 2 because we have y double prime here, so this will be r to the power of 2 minus 4r to the power of 1 because we have just single prime here, and then plus 4 multiplied by 1 because we have y without any prime here, which means r of 0, and r of 0 is 1, so 4 multiplied by 1 is just 4 equal to 0. So let's factor this out. We can see after we factoring this out, we will have r minus 2 and r minus 2 equal to 0. So r equal 2 and r equal 2, which means we got the repeated roots. And remember, every time you get a repeated roots, the general solution form should be y equal c1 e to the power rx plus c2 multiplied by x multiplied by e to the power rx. So let's find our general solution. Y equals c1 e to the power of 2x, 2 is our repeated root, and then c2 multiplied by x e to the power 2x, our repeated root, our second repeated root. So this is the general solution form. To find a particular solution, we have to plug our initial condition and the general solution. What does this mean is, so our first initial condition says y of 0 is equal to 1. So let's plug 1 for y, and every x you see it in the general solution, you have to plug it with 0 because our initial condition is y of 0 is equal to 1. So x equal to 0. So this will be 1 equal to c1 because it's a constant, e to the power of 2 multiplied by 0, so e to the power of 2 multiplied by 0 plus c2 multiplied by 0 because we have x here, and then e to the power of 0, which gives me 1 equal to c1 plus 0, so c1 is equal to 1. Our second initial condition says y prime of 0 is equal to 1. So this means we have to find the first derivative of the general solution. So to find the first derivative is y prime equal to c1 will be c1 because it's a constant, and then e to the power 2x is e to the power 2x multiplied by 2 plus c2 is a constant multiplied by the derivative of x, which is 1, multiplied by e to the 2x here, and then plus c2, and then this is x multiplied by the derivative of e to the 2x, which is e to the 2x multiplied by 2. Okay, so now let's say y prime of 0 is equal to 1. So y prime should be equal to 1, and any x we should plug it with 0. So c1 2 e to the power of 0 plus c2 e to the power of 0 plus c2 multiplied by 0 e to the power of 0, which means 0. So 1 equal to 2 plus c2, which gives me c2, the second constant should be minus 1. So now we just have to go and plug our constants c1 and c2 back in our general solution to find the particular solution. So y equal to, we have c1 as 1, so 1 multiplied by e to the power of 2x minus, because c2 now is minus 1, so minus x e to the power of 2x, and this is what we have. So this is the final particular solution.